Okay, the first unit in the grade 9 course is what we call numeracy. And you might think you know a lot about numbers, and hopefully you do, but this is just to consolidate knowledge that you've gained over your school year so far. So our unit goals are the following. First of all, for us to have a working knowledge of the number system. Also, that we can perform operations with integers, rationals, and radicals. And finally, well, sorry, not finally, applying exponent laws. And finally, ratio, rate, percent conversions and calculations. So those are the items that we will be studying in this unit. Okay, make sure that you take your note every night and that you come prepared to class to work. Okay, so let's look at the first today's goal. Today's lesson goal is I can sort numbers into their appropriate number systems. Now, whether you realize it or not, there is more than one number system that human beings use. In fact, there are 5 different number systems that you are responsible for this year. There are more number systems than 5, however, we're only responsible for 5. So let's look at the first number system. Now, the first number system is, I'm going to take you back to when you were a little child and you're about 3 years old, and someone would come up to you and they would ask you, "So how old are you?" And you would hold up your fingers and you would count each finger. And those are what we call the natural or the counting numbers. And what we do with the natural and counting numbers, we use the capital letter N when we're talking about natural numbers. Now, natural numbers we used to count with, or numbers above zero that do not have decimals or fractions. So that's what a natural number is. So it has to be a whole number, but it has to be above zero. And if we look at that, what kind of examples can we look at? Well, examples would be, just as I said, counting numbers, 1, 2, 3, 4, 5, etc. Okay, notice we don't include zero. The next number system that you learned, and probably when you started entering school, and it was a new number, and that number system is called the whole number system, and we use the capital W for whole numbers. And these were all the natural numbers, so everything from number 1 plus 0. Okay, so it's a little bit different because how do you count 0? You can't really count 0, so that's why it's not really a counting number. And I'm not going to do examples because it would be exactly the same as above, except we would have 0 as well. The next number system was a system that they told you included integers. Now, integers are positive and negative numbers. However, they do not have decimals or fractions. Okay, so they're like whole numbers that can be negative or positive in a sense. Okay, and then you're asking, what about 0? Is it positive or negative? Well, 0 is kind of special, so we don't consider it positive or negative. The next number system, now this next system, our fourth system, is what we call rational numbers. Okay, and for rational numbers, for whatever reason, they use the letter Q. You would think that would be R, but we save R for real numbers. So we call it Q. Now, Q, rational numbers, are numbers that can be written in the form A over B, where B does not equal 0. Okay, so when you see something that's like that, you're thinking, oh, a fraction. You're right. So rational numbers are fractions or numbers that can be written as fractions. And it includes decimals that repeat or terminate. So that's important. So it can include decimals, but they must be able to be repeated decimals or terminate. Now the reason being is you can actually then write them as in a fractional form. Okay, so examples of this would include 0.3. 0.125, and the line above remains repeating. So it would be 0.125, 125, 125 forever and ever. Or it could be 0.5 repeating. Okay, or it could be a whole number such as 2. And why is 2 a rational number? Well, because I can write 2 as 2 over 1. So that means I can put it in that form. If I can write it in the form like this, where the bottom, the denominator, doesn't equal 0, then it also is a rational number. Now, notice 2 is also an integer, right? And it's also a whole number, and it's also a natural counting number. So sometimes numbers can fit into more than one category. Okay, so that's what rational numbers are. Now the fifth number is a little bit different again. And we call these not rational, but irrational numbers. And the letter that they use for irrational is Q, but what they do is they put a line above the Q. Okay, so it's like a repeating sign symbol, but that's not what it really stands for. So irrational numbers, we use Q with a slash above the letter. Now these are numbers that cannot be written in the form a over b, where b can equal 0. And it includes non-terminating and non-repeating decimals. Okay, so this is like a separate category all by itself. So if you're irrational, you can't be rational, obviously, right? Because if you can't be written in the form of a over b, you can't be a rational number because you have to be in the form a over b. Okay, so examples of this would include things such as pi, which is a number, the square root of 3, the square root of 8, the square root of 10. So it includes root signs. And also what we need to point out too is radicals, okay, such as square roots. Okay, so these are radicals. Once you have a root sign, it's called a radical. Square roots that are perfect squares are not irrational numbers. And so that includes numbers such as 4, square root 4, square root 9, square root 16, because those numbers actually equal 2, 3, 4. Okay, so almost all other radicals, however, are irrational numbers. So what we're going to do now is we're going to turn the page and we're going to put it all together. So on this page, what we have is a Venn diagram. You've seen these before in other courses. So what we're talking about, this whole thing represents all the numbers, all the real numbers. And within the real numbers, we have what we call our natural numbers. Those were the counting numbers. Included then with that, the natural numbers are also included in what we call whole numbers. And these were 0 plus all the natural numbers. Then we ended up having what we called integers. Integers were positive and negative numbers that didn't include didn't include decimals or fractions. And we also had what we called rational numbers. So these were numbers that could be written as a fraction. And if you notice, a natural number would be a whole number as well as an integer as well as a rational number. Okay, an integer could be a rational number. It may be a whole number, but not necessarily, especially if it's a negative number, it wouldn't be. And then what we have here in this pink is a little group all by itself, and that's called the irrational numbers. Right? So for some people, they find it easier to keep track of the number system using a Venn diagram. Now, what are you expected to be able to do with this? Well, a few different things. The most basic thing is you should be able to check off what numbers belong in what number system. So let's take a look at our first example. And I'll be perfectly honest, this type of example, this type of question is usually on a test. So you might want to then put a star, well, or star usually means important. I'm going to put a happy face. Happy face means it'll probably be on a test. So let's do a check mark for the things it belongs to. Well, the number 3. Is it a natural number? Yes, it's a counting number. Is it a whole number? Yes. Is it an integer? Yes. Can I write it as a fraction? Well, I could. I could go 3 over 1. Okay, so now because it is a rational number, it cannot be an irrational. Okay, the next number. The next number I know is negative 10 over 2, which also is the same as negative 5. Okay, so let's take a look at that. Is it a counting number, a natural counting number? No. Is it a whole number? Well, I'm not sure. Let's go back and look at the definition. Okay, a whole number is all the natural numbers plus 0. Okay, it doesn't include negative numbers, so it can't be a whole number. Is it an integer? Yes. Can I write it as a fraction? Sure, negative 5 over 1. Okay, because it is a rational number, it can't be irrational. Now let's take a look at the next number. It says 2.68461 ... forever. Okay, so it's a decimal. Now some decimals are rational, some are irrational. Does this repeat? Well, there's a 6 and here's a 6, but this follows by an 8, this follows by a 1. So it is an irrational number. It's not terminating and it's not repeating. If I look at the number 1.3535, okay, so is it rational or irrational? Well, if I look, does it repeat? Yes, it's going 0.3535 forever and ever. So it is this. Now, is it an integer? Well, an integer, if we go back to our definition, an integer says it can never have decimals or fractions. Well, we have a decimal, so therefore it can't be an integer. Okay, and then we're left with the number 0. Well, the number 0, remember I told you, is not a counting number. You can't count 0. It's just 0. It is a whole number. Is it an integer? Yes. And can you write the number 0 as a fraction? Sure. 0 over 4, 0 over 5. Okay, so that means it's not an irrational. So as I said, this type of question could easily be on a test. Okay, now let's look at another type of example. It says provide 3 examples of each of the following. Okay, so we're going to go through this fairly quickly. Natural numbers. You don't have to go too far with that. Natural numbers, counting numbers, 1, 2, 3. Whole numbers, 0, 1, 2, 3 if you want to keep on going. Integers. Well, these are negative numbers that don't contain decimals. So -1, -2, -3. Rational numbers. So these are numbers that can be written as fractions, or they also could be perfect square roots, such as root 9, or they could be repeating decimals. And the last one is irrational numbers. So most of these would be radicals, things that are underneath the square root, such as square root 11. It could be the number pi that goes on forever, or it could be a decimal number that does not terminate or repeat. Okay, so that is the number system that you've been working with for the last few years actually. And what you're going to do tomorrow in class is you're going to work on the handout related to number systems.